Вот это надо отучиться. This is the theme of our lecture. So, no, at first, no, this is about for your remember, because acute phase response, these reactions appears or may appears after or during acute inflammation or maybe chronic inflammation. And you know that the main cells which take part in acute phase response are neutrophils and macrophages, monocytes. So this curve, remember you that neutrophils appears in the region of acute inflammation begin from 2 hours from injury and are maximal its number during 4-6 hours, and during 2 days its number decreases. When the number of neutrophils begin to decrease, monocytes increase its number, and in 10 times more than in a healthy situation, and stay increased up to the end of inflammation. Now, this is the definition of acute phase response. It is a non-specific response of whole organism, systemic reactions to severe injury or disturbance homeostasis. What is the sense of acute phase response? Now, at first it will be to defend our organism against severe injury. There will be the first. The second, it may be regulatory of some systems, regulatory of some systems, and homeostasis. What is the cause of appears acute phase response? No, it may be the all pathogenic factors which can lead acute inflammation. The first. The second, it may be infectious causes, maybe uninfectious causes. It may be acute or chronic inflammation or acute or chronic diseases. Now, for example, myocardial infarction, it is acute inflammation, but myocardial infarction leads to acute phase response. Now, chronic, for example, glomerulonephritis, chronic glomerulonephritis lead to acute phase response, systemic reactions. What else? This picture shows you at the beginning of this picture injury of tissue, very many causes in the first position here on this picture, and then lead to local reaction during inflammation. And during this, there is activation of very many cells. The main are neutrophils, monocytes. There may be fibroblasts, endothelial cells, and very many other cells. And these cells can secretion the cytokines. They can secretion and release in this local zone of inflammation. Interleukin-1, interleukin-6, tumor necrosis factor, interferon, gamma, and the others. And with the help of bloodstream, these cytokines spread all over the organism. And that is why there appear systemic reactions. And below of this picture, you see the yellow color boxes where there is the effect of activation of these systems. Central nervous system lead to appears fever. The endocrine system, activity of adrenal gland, pituitary, hypothalamus. That is why there appears increased ACTH, and so increased concentration of cortisol. Liver lead to begin to synthesize the acute phase response proteins, and so on. What is the main clinical symptoms of acute phase response? They are fever, neutrophilia, and erythrocyte sedimentation rate. This picture shows you the effect of cytokines on something region of organism. On the left, there is the stimuli which can activate macrophage to secrete these main cytokines. You see, there will be, at first, monocytes are in the blood. That is why there will be activation of endothelial cells. And endothelial cells begin to secrete two cytokines. And these cytokines will stimulate endothelial cells to increase adhesion molecules. As for fibroblasts locates in connective tissue. So activation of fibroblasts lead to formation and secretion of collagen. It may lead to scar and finish the inflammation. In the bloodstream, cytokines activates, not in bloodstream, cytokines can activate the specified cells. These cells, in turn, will secrete granulocytosis, monocytosis, colony stimulating factor. This factor comes in bone marrow and stimulate the production of granulocytes. There may be the changes in metabolism. Now about fibroblast, I told you, changes in metabolism. Now, you see, during acute phase response, the organism loss of body mass, and sometimes it may lead to cachexia, because interleukin-1 influence on central nervous system, and this will lead to decreased appetite. The first, the second, cortisol, which concentration increases in acute phase response, decreased production of proteins, and increased gluconeogenesis, breakdown of proteins. And another cause which may lead to cachexia. Negative nitrogen balance. No, this appears due to that this is decreased protein synthesis. Decreased activity of lipoprotein lipase in muscles and fat tissue. This is another cause which lead to cachexia, or may lead to cachexia. What else? You see, there appears the proteins of acute phase response, and we will discuss further its mechanism, its effect on organism. Osteoporosis, another cause which may lead to cachexia, because it will lead to a breakdown of bone and cartilage. And another effect will be increased activity of osteoclast, and which break down the bone tissue, and decreased activity of osteoblast, which stimulate to increase growing of bone tissue, and decreased collagen synthesis, because collagen must be break down by collagenase, which is activated by tumor necrosis factor. No, neuroendocrine changes. No, at first it will be fever, increased body temperature, and there will be, as I told you, loss of appetite, increased secretion of antidiuretic hormone, and ACTH in hypothalamus. And the complication of it, you understand, increased antidiuretic hormone lead to keep water in organism. Increased ACTH lead to activate adrenal gland, and this will lead to release cortisol, glucocorticoids. As for hematologic changes, you see, due to decreased transferrin, this is effect of transferrin protein. This is the protein of acute, negative protein of acute phase response. So there will be decreased transport the iron and that is why there appears iron deficiency anemia. Then there will be a decrease. No, as I told you, increase the fibrinogen in blood, so this will lead to increased erythrocyte sedimentation rate. The main mediators or cytokines of acute phase response are interleukin-1, interleukin-6, and tumor necrosis factor alpha. What I told you, the difference between mediators and cytokines. You see, mediators release from, for example, acetylcholine will release from nerves ending and influence on its own receptor, for example, on muscles. As for cytokines, they not only release from some cells such as neutrophils or monocytes, and they influence on its own target cells, because very many cells have the receptors to these cytokines, but at the same time they will influence on the cell which secretes these cytokines. So there appears some processes which increase their secretion for prolonged time. And further, we will discuss the effect of all cytokines which take part in acute phase response. You must understand that interleukin-1 can synthesized by monocyte, macrophages, endothelial cells, and neutrophils, you see. And to the family of interleukin-1 belong interleukin-1A, interleukin-1 beta, and the antagonists of interleukin-1 receptor. So this receptor is soluble, or may be soluble, maybe binds to plasma membrane. And it is important to know, because you must know how to treat the person with severe effects of acute phase response. So, I will show you the picture. What at first you see the red one. This is the formation of interleukin-1 beta. You see, interleukin-1 beta receptor, and so look, the red one, it will be receptor, you see, and consists of two boxes. It comes to plasma membrane, binds to plasma membrane, and on this plasma membrane is activated the enzymes, and this enzyme break it down, and one of comes in the blood, and in the blood swim matured interleukin-1 beta. At the same time, it may be activated the interleukin-1 beta, not matured at all. The green picture here there is belong to interleukin-1A. You see, it will bind to the membrane and stay there. Sometimes it will release from the cells and with the help of enzymes break down into 2,1, and that is why appears matured interleukin-1A. Now, you see, these pictures show you that cytokines are transmembrane receptors, and that is why they have intracellular domains and outercellular domains. No, and further, the effect of interleukin-1. As I told you about the interleukin-1 and its influence on the central nervous system is the main among another cytokines. And interleukin-1 appears fever, increased synthesis and secretion of antidiuretic hormone and ACTH. Then, if it is influence on central nervous system, there will be what? Another effect. Sleepiness, apathy, you see, and decreased appetite. As for changes in blood cells, the main is neutrophilia, then lymphopenia, and thrombocytosis. No, neutrophilia, this is a specified effect of interleukin-1, interleukin-6, and granulocytosis colony stimulating factor. But from one hand, the other hand, it is the effect of cortisol. You see, you remember hemopoietic effect of cortisol, increased neutrophilia and erythrocyte, and decreased lymphocyte and eosinophils. As for cardiovascular system, interleukin-1 can increase or decrease blood pressure, then increase cardiac output and increase heart rate. Now, you understand? The last two is the effect of sympathetic nervous system, means interleukin-1 can activate sympathetic nervous system. No, on its effect on wall vessels, stimulation endothelial cells to increase adhesion molecules for leukocyte, and this is lead to increased phagocytosis, you see, and stimulate phagocytosis. From one hand, it is a pro-inflammatory effect. From the other hand, it may be anti-inflammatory because increased phagocytosis lead to decreased injurious agent. As for metabolism, again, there is the positive and negative effect. Now, at first, it is decreased synthesis of albumin in liver. You see, this is a negative effect of proteins in acute phase response. You see? And another one, it will be inhibits the lipoprotein lipase. So this will decreases formation of fat tissue and proteins. Another one, interleukin-1 can activate T and B lymphocyte. You see, that is why it will increase immune reactions in organism. Activation of immune system is a protective effect for our organism. There is negative effects of interleukin-1. Now, at first, fever. If we think about fever, when body temperature is below 38 degrees Celsius, this is good for organism because in high temperature, the velocity of biochemical reaction is quicker than in normal degree. But if the temperature of body, temperature of blood is higher than 38 degrees Celsius, this will lead to denaturation of proteins, we know. And this will lead to stoppage of work of any enzymes in organism. That is why it is negative effect. Then rheumatoid arthritis. You see the same. If the body temperature is below than 38 degrees, there is activity of all the cells, you see, and higher temperature lead to stoppage of phagocytosis, and it may increase effects, negative effects on joints. You see? Pain in muscles and joints. What you must understand, when you are catch diseases, you see and you feel the pain in muscles and joints. But it is not the inflammation in muscles and in joints. This is a negative effect of interleukin-1 on the brain, and it will activate the excitability, increased excitability of neurons which are in pain pathways. That is why this is the effect of activation pain pathways due to effect of interleukin-1 on the central nervous system. Now, decreased blood pressure, and sometimes it can be decreased blood pressure, and it is not good because this will lead to ischemia. Destruction of bones and cartilage, and destruction of and disturbance of microcirculation, because activation of thrombocyte may lead to formation of thrombus. That is why there will be disturbance of microcirculation. Now, this is about rheumatoid arthritis and interleukin-1 in rheumatoid arthritis. So, on the left, there is normal. You see, T cell, T cytotoxic lymphocyte, which can inhibit T helper, and macrophage can release interleukin-1, which activates this T cytotoxic. You see? On the right, there is the same, not same, there will be the another behavior of macrophage. Look, it will right lower corner, you see, macrophage can release interleukin-1, which influence on chondrocyte, and this will lead to destruction of cartilage. You see, the first. From the other hand, it will influence on osteoclast, activates these cells with green, and this will lead to restriction of bone. Why it will be? I would look here. From this macrophage, it will influence on collagenase, and collagenase will activate T helper and at the same time T cytotoxic. So T cytotoxic will not inhibit T helper. That is why there will be activate B cells, plasma cells, and there appears antibodies. And these antibodies will influence on macrophages. That is why there appears a vicious circle. You see, for prolonged time, there will be activated macrophage, which release again T helper factor, which can activate it, and so on. Так, ну, это допустим. Да. So, this is about the treatment of effects of interleukin-1, negative effect of interleukin-1. Now, at first, you see, there may be antibodies to interleukin-1. Now, you know, how can it do? You see, interleukin-1 is protein. That is why the small concentration of these interleukin-1 can inject to rabbits, and rabbits, because interleukin-1 is foreigner for it, begin to synthesize antibody against interleukin-1. And so when you injured to human being who suffered from severe acute phase response and effects of interleukin-1, you will decrease its effect. Then, soluble receptors for interleukin-1. Then, glucocorticoids. Now you understand, glucocorticoid blocks the interleukin-1 synthesis, and inhibition of interleukin-1 convertase means there will be decreased formation of interleukin-1A and interleukin-1B. Then blocks of interleukin-1 receptors on the membrane of target cells. There may be used of antagonists to these receptors and antibodies to receptors of interleukin-1. Look what this picture is illustrate the treatment for negative effect of interleukin-1. What you see, this green figure is interleukin-1. The first picture show you what are there in normal. The blue is receptor, red is the membrane of some cells. So these interleukin-1 binds to its own receptors, and there appears inflammatory effect. What will be here? You see, there is monoclonal antibodies to interleukin-1. That is why these antibodies catch this green immunoglobulin E, immunoglobulin G. There will be catch interleukin-1. That is why no effect inflammatory. The first. The second, there may be the blockage of receptors. You see, on these bluish receptor binds to some black something. This is receptors to immunoglobulin E. Next picture, the third. You see, the blockage of, look, this one is antagonist, the red one. Another antagonist to receptor, red, the structure binds to bluish one. So no inflammatory effect of the cell. Another, there is antibodies to receptors. So there is destruction of receptors, and that is why absent of inflammatory effect. Then here there is the blockage they used the anti-inflammatory cytokines. You remember previous lecture, anti-inflammatory cytokines are interleukin-4 and interleukin-10. They binds to receptors, and they will be absent of inflammatory effect of interleukin-1. Now, toll-like receptors, I will not tell you about information because it is additional information and we have no time to discuss about it. So this is the effects of tumor necrosis factor. And you know that tumor necrosis factor is the main or has the main role in rheumatoid arthritis because macrophage is activated, you see, and after that can secrete all the cytokines, all cytokines. No. And you know that tumor necrosis factor can make the cells, monocyte, macrophages, neutrophils, eosinophils, T and B lymphocyte, to secrete all cytokines. That is why in the region of inflammation appears all cytokines there in high concentration, and that is why there appears the very many adhesion molecules on the endothelial cells, icons, and you know, appears these molecules lead to catch neutrophils or monocytes, and that is why catch and made them stay near the wall vessels and further to the epidermis, and then comes to the region of inflammation, means comes to the joints. You see, that is why there appears a lot of leukocyte which altogether come through the wall vessels in the region of inflammation. So the inflammation begin more severe. But on the other hand, right side of this picture, you see tumor necrosis factor can influence on the hypothalamus, increase production of ACTH, increase its effect on adrenal gland, further from adrenal gland release cortisol, and cortisol will decrease effect of these cells. This is again about the effect of tumor necrosis factor. There is about its effect on the joints. You know, in joint, in bone tissue, there are osteoblasts, osteoclasts, you see, and fibroblasts, and all of them will activate metal proteases. Metal proteases will destroy the joints. Now, this is again about the damage of joints. You see, the first picture is normal joint. You see, there are a lot of cartilage, and there will be increased bone tissue, you see, and if it will be beginning of arthritis, you see, inside of bone tissue, you find neutrophils You see? Due to the nuclear monocytes here, and they will begin to release cytokines, and further there appears very many cells, increase the thickness of capsula, this red one, you see, and the bone tissue decreases in the length, and the last is, you see, with these white line. This is the cartilage, you see, cartilage decreases too, the bone tissue decreases too, and that is why there appears the arthritis. This is another main cytokines in acute phase response, interleukin 6. Its main effect is on the liver to produce the acute phase response proteins. No, except these, interleukin 6 can influence on fibroblasts and increase their proliferation. Further, it will stimulate hematopoiesis. I told you that interleukin 6 take part in increased neutrophils in blood during acute phase response. Further, it will activate T lymphocyte. This is about take part of interleukin 6 again in increases of metalloproteases, and that is why it takes part in damage of joints. No, this is, and we will pay attention for its effect on the liver, and liver will synthesize the proteins of acute phase response. You see, there are 3 groups of acute phase response proteins. At first, there is protective, means increased inflammation. They will be C-reactive proteins, C3 fragment of complement, and serum amyloid A. Anti-inflammatory, ceruloplasmin, alpha-1 antitrypsin, and alpha-1 anti-chymotrypsin. And the last group transported, ceruloplasmin for copper and calcium, haptoglobin for hemoglobin, and transferrin for iron. Return back to. So, C-reactive protein. This is the protein which concentration in acute